In the previous video, I mentioned to you that you need to identify the different blocks on the periodic table. You have your S, your D, your P, and your F. Then I asked you to go through and number. Let me change the color here. Your 1 and 2. That's not quite dark enough. Let me try a different color. Right. You have 1 here and 2. And you would number 1, 2 all the way down. You have 1 through 6 from boron to neon, and you would number 1 through 6 all the way down. You have your D block numbering 1 through 10, and your F block numbering 1 through 14. All right, and so to summarize what was done before, you have the main energy levels, which are represented by the period numbers 1, 2, 3, 4, 5, 6, and 7. Those are your main energy levels. And then your sub-levels are represented by your S, P, D, and F. And then when we're drawing our orbital notations, our orbitals are going to be represented by lines. And the electrons will be represented by arrows. Now I draw my arrows a half arrow, but if you prefer to draw a full arrow, that's fine too. Either one, they represent the same thing. So let's start with helium, or excuse me, hydrogen. Hydrogen has 1 electron, all right? And so whenever we write these orbital notations, we always have to start with the lowest energy level. The lowest energy level is always period 1. So I'll start with a 1. And then the next thing is a sublevel. Hydrogen is an S block element, so I will write the letter S. The S sublevel only has 1 orbital, so I'm going to draw my line. Now, hydrogen has 1 electron, and since we're only drawing 1 electron, that 1 electron has to have a positive 1/2 spin. That is the orbital notation for hydrogen. Next, we can take a look at helium. Helium has 2 electrons. So again, we have to start with the lowest energy level, which is 1. The first block of elements that you come to, S. The S sublevel only has 1 orbital. Now helium has 2 electrons. So when drawing those 2 electrons, we know that since they're going in the same orbital, they have to have an opposite spin. So the first electron we have has a positive 1/2 spin. The second electron has a negative 1/2 spin. That is the orbital notation for helium. Let's take a look at beryllium. Beryllium has 4 electrons. And beryllium is in the second period, so beryllium has a total of 2 energy levels. But we still have to start with the lowest energy level, which is 1. So I'm going to draw a 1. The first sublevel we come to is S. The S sublevel has 1 orbital. So we have 2 electrons to draw. So I'm going to draw 1 up and 1 down. So I've drawn 2 electrons that have opposite spins in the same orbital. So after we are done with this first energy level, 1, you move down to the second energy level. And now we have the second energy level. The first block or the first sublevel we come to is S. The S sublevel has 1 orbital. So we've drawn 2 electrons. So we subtract 2 and now we have 2 electrons left to draw. Beryllium has, the S sublevel can hold 2 electrons. Beryllium, there are 2 electrons left to draw. So with those 2 electrons, we're going to have a positive 1/2 spin and a negative 1/2 spin. So we've now drawn the electrons. for beryllium, and beryllium has 4 electrons. 1, 2, 3, then 4. Let's take a look. Let's take a look at some other orbital notations. Sorry about that. See if I can erase this. Wow, no luck. Try to erase some of these without deleting the entire periodic table, and I'm not having any luck. So let me try it up here so I don't have to keep starting over. All right, let's take a look at nitrogen. So right here, nitrogen has 7 electrons. We always have to start with the lowest energy level, but we know that since nitrogen is in the second period, there would be a total of 2 energy levels. So I'm going to start with the first energy level, which is the lowest, 1. The first sublevel you come to is S. The S sublevel has 1 orbital. So we have the first 2 electrons here. So we're going to draw a positive 1/2, negative 1/2. So if I subtract 2 electrons, I now have 5 electrons left to draw. So now that we're done with the 1s sublevel, I'll move down to the second energy level. The first sublevel I come to is S. The S sublevel has 1 orbital. I'm going to put 2 electrons, positive 1/2, negative 1/2. So now I'm going to subtract out 2 electrons, and that leaves me with 3 electrons left. So if I move across the second period, I'll now come to nitrogen. All right. So if you remember back, the P sublevel has 3 orbitals. So I'm still in the second period. So I still have the second energy level, but now I have to draw the P sublevel. The P sublevel has 3 orbitals, so I'm going to draw 3 2p orbitals, again because the P sublevel has 3 orbitals. Now, here's a rule that was not mentioned before, and this rule is that every orbital has to have 1 electron before I can double up and put 2 electrons in an orbital. So I have 3 electrons to draw. Every orbital has to have 1 electron before I can double up and put a second electron. So this is an orbital notation for nitrogen: 2, 4, 5, 6, and 7. All right, let's look at one where we will double up. Let's look at fluorine. All right, let me try my hand at this and see if I can get these to erase, and no such luck. So I will come down here to the bottom. All right, so fluorine has 9 electrons. All right, so I'm right here at fluorine. We start with the lowest energy level, which is 1. The first sublevel we come to is S. The S sublevel has 1 orbital. The maximum number of electrons that can go in that S orbital is 2, and so we place them 1 up, 1 down. So now that we fill this S sublevel, we now move down to the second energy level, which is 2. The first sublevel we come to is S. And if you notice, we're starting over every time. The S sublevel has 1 orbital. So I've drawn 2 electrons, so that leaves me with 7 electrons left to draw. So the S sublevel can hold 2 electrons, 1 up, 1 down, positive 1/2, negative 1/2. So I draw and subtract out another 2 electrons, so now I have 5 electrons left. I'm done with 2s, So now I move over to my P sublevel. I'm going to draw 3 2p's because the P sublevel has 3 orbitals. And as I stated before when working on nitrogen, every orbital has to have 1 electron before any orbital can have 2. So now I have 5 electrons left to draw. So I'm going to draw 1, 2, 3. Now that each orbital has 1 electron, I can go back and double up. So that's 1, 2, 3, and then I'm going to start over at the far left. 4, 5. So now let's count the electrons to make sure I've drawn 9 electrons for fluorine. 2, 4, 6, 8, 9. Those are your 9 electrons for fluorine. Alright, review this video and we will practice more in class when I see you next time.